Welcome to this Viva Voce video on Newton's rings. This video will explore the key concepts, principles, and applications of the Newton's rings experiment. We begin with some multiple-choice practice questions. First, the fundamental physical principle behind Newton's rings is the interference of light. Second, this is an example of interference by division of amplitude. Third, the fringes appear circular because they are the locus of equal air film thickness. Question 4. In reflected light, the central spot is dark due to destructive interference. 5. The phase change occurs because light reflects off a denser medium, which is the glass plate. 6. A plano-convex lens with a large radius of curvature is used to produce widely spaced, easily measurable rings. Question 13. If the lens is lifted, the rings collapse towards the center. Question 14. In transmitted light, the central spot appears bright due to constructive interference. Question 15. The refractive index of a liquid is determined using the ratio of the squares of the diameters of rings in air and liquid. Question 7. The diameter of dark rings is proportional to the square root of the ring number. 8. The fringe width decreases as you move outward from the center. 9. The 45-degree glass plate is used for normal incidence, reflecting light perpendicularly onto the lens. Question 10. Monochromatic light is required for distinct and sustained interference patterns. 11. Using white light results in a dark center surrounded by a few colored rings. 12. If a liquid with a refractive index greater than 1 is introduced, the rings will shrink in diameter. We return to questions 13, 14, and 15, previously covered in scene 4. 13. Lifting the lens collapses the rings toward the center. 14. The central spot is bright in transmitted light. 15. The refractive index of a liquid is found using the ratio of the squares of diameters. Let's review some key questions and answers. 1. Newton's rings are alternating bright and dark circular interference fringes. 2. The fundamental principle is interference of light by division of amplitude. 3. The fringes are circular because they represent the locus of points with the same air film thickness. 4. The central spot is dark in reflected light due to destructive interference caused by a phase shift upon reflection from the denser medium. 5. A large radius plano-convex lens is used to produce widely spaced observable rings. 6. The 45-degree glass plate acts as a beam splitter for normal incidence. 7. Replacing monochromatic light with white light results in a dark central spot surrounded by a few colored rings. 8. The fringe width gradually decreases as you move away from the center. 9. A liquid with a refractive index greater than 1 causes the rings to contract or shrink in diameter. 10. Yes, Newton's rings can be observed in transmitted light, where the central spot appears bright. 11. An extended source is preferred over a point source to provide a larger field of view. 12. The lens and glass plate must be perfectly clean to ensure proper contact and avoid distorting the central spot. Let's review the key formulae. Wavelength calculation is based on the diameter of MTH and nth dark rings. The refractive index calculation uses the ratio of the squares of the diameters in air and in liquid. Finally, the ring diameter for dark and bright rings are proportional to the square root of the ring number. Thank you for watching this video on Newton's rings. We hope this guide was helpful for your preparation. Please like and subscribe for more educational content.